theme is post-pandemic challenges and opportunities on green technology and engineering. A quick word about this morning's conference opening ceremony. We shall begin with the national anthem, Indonesia Raya. The next item is the welcoming remark by the conference committee chair. Finally, the rector of Universitas Negeri Yogyakarta will be delivering his opening speech afterwards. It will be followed by the sessions from the keynote speaker and the invited speakers. Distinguished guests, ladies and gentlemen, now would you please be silent and bow our heads for a moment to have a prayer. Let's say our prayer, shall we? Thank you. The national anthem, Indonesia Raya. Ladies and gentlemen, would you please kindly rise? Please be seated. Now we are going to listen to the welcoming remark from the conference committee chair. Ladies and gentlemen, please welcome the Dean of the Faculty of Engineering of Universitas Negeri Yogyakarta, Professor Herman Dwi Suryono, MSc, PhD.
Assalamualaikum warahmatullahi wabarakatuh. May peace and God's blessing be upon you all. His Excellency, Coordinating Minister of Human Development and Culture Affairs of Indonesia, represented by Bapak Insinyur Aris Darmansyah Edi Saputra MN, PLT Deputi Bidang Koordinasi Peningkatan Kualitas Pendidikan dan Moderasi Beragama. The Honorable Rector of Universitas Negeri Yogyakarta, represented by Vice Rector for Academic Affairs, Bapak Profesor Dr. Margono M. Hum. The invited speakers, the representative of Universitas Sarjana Wisata Tanma Sinswa as co-host, the Vice Rectors, Deans of all faculties, Director of Graduate School, Heads of Institute, Heads of Bureau, Vice Dean of Faculty Engineering, Heads of Department and Study Program. Good morning, ladies and gentlemen, fellow speakers. Good morning to all audience joining us online. First of all, let's thanks to God the Almighty who has been giving us His mercy and blessing so we can meet here on this great vocation. Allow me to extend our warmest greetings and welcome to the keynote speaker, all guest speakers of parallel session, and all participants of the Third International Joint Conferences on Engineering Technology and Vocational Education, held by Faculty of Engineering, Universitas Negeri, Yogyakarta. Raising the theme of post-pandemic challenges and opportunities on green technology and engineering. This conference is designed to share knowledge and awareness on the learning quality regarding technology and vocational education in post-COVID world. This joint conference includes the 8th International Conference on Technology and Vocational Teachers, ICTVT, the 5th International Conference on Electrical, Electronic, Informatics, and Vocational Education, ECL Info, the 4th International Conference on Vocational Education of Mechanical and Automotive Technology, ISOVMAT, and the 5th International Conference on Sustainable Infrastructure, ICSI. Ladies and gentlemen, in this occasion, I would like to express our gratitude to our keynote speakers and invited speaker. First, His Excellency, Coordinating Minister for Human Development and Cultural Affairs of Indonesia. To Professor Cheng Xiao Liu, National Taiwan University of Science and Technology, Taiwan. 3. Professor Lee Seon-ha, Gwangju National University, Republic of Korea. 4. Associate Professor Ferry Ji, Edith Cowan University, Australia. 5. Professor Oliver Michler, Technische Universität Dresden, Germany. 6. Professor Didik Nurhadianto, Universitas Negeri, Yogyakarta. They will share their insight and valuable experiences that I strongly believe it will be beneficial input for all of us. In the parallel session this afternoon, there are 160 presenters will present the result of their thought and research, which of course will be very useful in supporting the recovery effort in the field of education and technology. Speakers come from 7 different countries from all over the world. Our highest appreciation also goes to all committees that have worked hard to manage these conferences. Finally, I would also like to apologize for shortcoming and any inconvenience during this event. Wish you have a productive discussion and fruitful conference. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, may we invite the Rector of Universitas Negeri Yogyakarta, represented by the Vice Rector for Academic Affairs, for the opening speech, at the end of which we would also like to kindly request the Vice Rector to officially declare the 3rd Joint International Conference on Engineering and Vocational Education open straight afterwards. Professor Dr. Margana M. Hum, MA, the floor is yours.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. His Excellency Coordinator Minister for Human Development and Culture of Indonesia, Bapak Professor Dr. Muhajir Effendi MAB, in this occasion represented by Deputy for Coordinating Section of the Enhancements of Education and Interreligious Modernization Quality, Bapak Insinyur Aris Darmansah Edi Saputro M.Eng, as the keynote speaker in this conference. The honorable invited speakers, Vice Rectors of Yogyakarta State University, Vice Rector of Cooperation and Public Relation Affairs of Sarjana Wiyata Taman Siswa, Yogyakarta, Dean of Faculty of Engineering of Yogyakarta State University, all deans, Director of Graduate School of Yogyakarta State University, and then Head of Bureau of Financial and Public Administration Affairs, Head of Watas and Gunung Kidul campuses, Vice Deans of Faculty of Engineering, Heads and Secretaries of Departments, Coordinators of Study Program, all lecturers at Faculty of Engineering, the chairpersons of the conference committee, ladies and gentlemen, and other participants. First of all, let us thank Allah, the Almighty, for blessing and guiding us into the right path and for granting all means opportunities to gather here to attend this very fruitful and tremendous occasions of the 8th International Conference on Technology and Vocational Teachers, as abbreviated ICTVT, in collaboration with 3 other international conferences, namely ICA Alin VO, and then ICSA and ICO FEMAT, as well as the collaboration between State University Yogyakarta and Sarjana Wiyata Taman Siswa Yogyakarta. It is greatly honored and pleased for me, representing Rector of Yogyakarta State University, Professor Dr. Sumaryanto M.Kes, to warmly welcome all of you in these hybrid conferences, virtual and face-to-face. Distinguished speakers, participants, ladies and gentlemen, it is evident that the COVID-19 pandemic has spread with alarming speed, infecting millions of people around the world, increasing the death rate of people, and bringing economic activity to a near standstill as countries impose tight restrictions on movement to minimize and halt or stop the spread of the virus at that time. But now we have been entering in the new normal of lives after pandemic of COVID-19, which drives us to establish creativity, innovation, and the like to the betterment of the quality of the lives. As we are all aware, the existence of the Industrial Revolution 4.0 directly or indirectly drives a great number of citizens of every country to highly acquire the literacy of digital technology on the grounds that it promises the betterments of human lives. Furthermore, a great number of companies, industries, institutions, and the like give an emphasis on efficiency, productivity, effectiveness, practicality, automation, and sustainability with the employment of high digital technology. This suggests that education at any level of at any level of education, the university level, should be concerned about establishing and generating agile graduates, including the graduates of vocational education, to meet the stakeholders' demands, which meet the ecosystem any situations, having radiant critical and creative thinking skills, having good communication and networks, being disciplined, being familiar with the ecosystems of work field, and others are able to cope with emerging problems in the 21st century with regard to sustainable and development goals called SDGs, which provide a various perspective on the COVID-19 pandemic era. It is evident that the pandemic can provide positive and negative impact on 17 SDGs dimensions. The positive value of pandemic is that the earth breathes without air pollution and global warming caused by restrictions on people's activities. On the other hand, poverty, health quality of education, unemployment, and many other targets have been affected by the COVID-19 disasters. Various research and innovations in the SDGs have begun to update the ways and methods of solving problems in guiding Indonesia out of the crisis period of the COVID-19 pandemic. In reference to the above issues, Faculty of Engineering of Yogyakarta State University is keen on responding to intensely establish the importance of SDGs, which consists of 17 areas to gain the quality of lives with regard to the three premises, Hablum minallah, Hablum minanas, and Hablum minalam. That is why the theme of conference today deals with post-pandemic challenges and opportunities on green technology and engineering. It is aimed at providing a forum for scholars, lecturers, researchers, teachers, stakeholders, practitioners, and students to intensively share ideas and experience under the topic mentioned and to make a collaboration across institutions and countries. Distinguished invited speakers, participants, ladies and gentlemen, to gain the objectives of the committee has succeeded in inviting some prominent expert as the keynote speaker and plenary speakers from different countries, as mentioned by the Dean of the Faculty of Engineering, 7 countries, namely the Coordinator Minister for Human Development and Culture of Indonesia, Bapak Profesor Dr. Muhajir Effendi, MAP, represented as the keynote speaker, the Deputy of Coordinating Section of the Enhancements of Education and Interreligious Modernization Quality, Bapak Ensign Aris Darmansyah ID Saputro MA. Thank you very much. And then Prof. Zheng Xiao Liu, PhD from Department of Electronic and Computer Engineering, National Taiwan University of Science and Technology. And then the third one is Professor Dr. Eng Ensir Titik Nurhadiantoro, MT Nurhadianto, MT IPU from Department of Mechanical Engineering Education, Yogyakarta State University, Associate Professor Ferry G, PhD, FC ILT, PCS, at Cowan University of Australia, and then Professor Dr. Lee Seon Ha from Department of Construction and Engineering, Konglu National University of Republic of Korea, Professor Dr. Ing Oliver Maser from Institute University of Dresden, and Associate Professor Very G, PhD, and I've already mentioned that one. And added on this, it is unwise to appreciate all delegates and participants who have managed to take part in today's conference. I do hope that this conference brings some benefits to all the participants and contribute to the upbringing of the scientific life. Distinguished invited speakers, participants, ladies and gentlemen, it is really aware that this conference could not have been made possible without any help from many parties, including the Dean of the Faculty of Engineering, Professor Hirman Dwi Sarjono Surjono, MSc, MT, PhD, and his staff members, the delegates from many institutions, the head of the committee, Associate Professor Dr. Sutiyatno, ME, and other chairpersons of the international conference, as mentioned earlier, and the committee members and others, and the rector of Universitas Sarjana Wiyata Taman Siswa Yogyakarta. And then therefore I should appreciate their work and dedication and express many thanks to them all. I do apologize for any shortcomings which you may find during this conference. Finally, I wish you gain a fruitful and pleasant forum and enjoy yourself during this virtual and hybrid conference. With the great word of Bismillahirrahmanirrahim, it is a pleasure for me to declare the official opening of the 8th International Conference on Technology and Vocational Teachers as abbreviated ICTVT in 2022 followed the other 3 international conferences. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Good morning.
Distinguished guests, all participants, ladies and gentlemen, this is the end of the opening ceremony of the 3rd International Conference on Engineering and Vocational Education. Thank you for your participation, and on behalf of the committee, I would like to apologize for any shortcomings and inconveniences. We are now proceeding to the next item of today's agenda, that is keynote speech. The keynote speech is delivered by the Deputy of the Coordination Section of the Education Quality and Religion Moderation Enhancement, representing the Coordinating Ministry for Human Development and Culture of Indonesia. Bapak Insinyur Aris Darmansyah Edi Saputra M.Eng, the floor is yours.
Okay, thank you. First of all, our ministry, Professor Dr. Muhathir Effendi, Coordinating Ministry, Minister for Human Development and Culture, said his regret that he could not join of us today due to the scheduling conflict. And on behalf of the Coordinating Minister, please allow me as Darmaja, as the Deputy of Education, Quality and Religion Moderation Enhancement, to deliver a speech on the occasion of the 8th International Conference on Technology and Vocational Teacher 2022. Assalamualaikum warahmatullahi wabarakatuh. Good morning and greeting. Shalom. Om Swastiastu. Namo Buddhaya. Salam Kebajikan Rahayu. The Honorable Director of Yogyakarta State University, Professor Dr. Sumaryanto, Vice Rector of Yogyakarta State University, Professor Dr. Argono, the Dean of Faculty of Engineering, Professor Herman B. Sidono, the distinguished speakers, Professor James Shule, Professor Dr. Oliver Michael, Professor Dr. Lee Xianha, Associate Professor Biology, and Professor Dr. Insinyur Didik Nurhadianto, MPIU. Ladies and gentlemen, firstly we thank to Allah Subhanahu wa Ta'ala for blessing us with blessing and mercy, so we are able to gather in the 8th International Conference on Technology and Vocational Teacher 2022 today. I would like to send my gratitude to the Dean of Engineering Faculty, Yogyakarta State University, for Engineering Faculty, Yogyakarta State University, for inviting me to this very important work. Distinguished guests, the COVID-19 pandemic that emerged roughly and spread throughout the world brought both positive and negative impact. The direct impact of the pandemic was the daily toil of our brother and sister. Pandemic has limited the activities of people around the world that brought a positive impact on the environment due to drastically reduced air pollution. However, the pandemic also triggered a global economic crisis and had a negative impact in the form of disruption of health and health services, education services, and industrial activities that led to enhancement our unemployment and poverty. New adoptions are urgently needed to overcome the impact of COVID-19 pandemic. Therefore, numerous policies have been implemented to encounter COVID-19 pandemic. Various research and innovations have been conducted to accelerate recovery, especially in economic and education sector. To welcome the post-pandemic era, the redesign of Indonesia economic transformation need to be enforced, which cover competitive human resource, green economy, integration of the domestic economy, enhancement of productivity in the economic sector, and digital transformation. This economic transformation requires constructive cooperation from various factors. The pandemic highlights the achievement of SDG target. Nevertheless, at the same time, it provides opportunities to reform value systems. For example, our energy concern toward the natural sustainability as the source of human life. Indonesia has proven its resilience during and after the COVID-19 pandemic. Indonesian economic growth is 3.69% in 2021, and it is estimated to increase to 5.3% for 2022 and 50.2% for 2023. In July 2022, the International Monetary Fund estimated the global economic growth for the period 2022 and 2023 was only 3.2% and 2.9% respectively. This indicates that Indonesia's economic growth is higher than most countries in the world. Ladies and gentlemen, as part of the society, universities have to be able to adapt the dynamic and challenges that occur in an increasingly complex society by providing various scientific breakthroughs. Therefore, we must afford the three dharma of higher education and university activities, namely conducting education, research, and community service. University conduct research as an effort to provide innovation and solution to various challenges experienced by society. Furthermore, this research is worthwhile as an input for the government in the policy making process. In the near future, research should be addressed to create green technologies for sustainable environment. Hence, collaboration between university and industry is the key to a sustainable in the university research ecosystem. An effective collaboration will provide innovation that is suitable for the market and society. Furthermore, a successful research collaboration between university and industry enables to accelerate the independence of universities to increase external research funding. Research funding support from industrial business sector is immensely needed. However, in 2022, the allocation of Indonesian research fund was still below 1% of GDP, while other countries had reached 3 or 4% of GDP. Ladies and gentlemen, currently, Indonesia is entering a period of demographic wellness, in which the productive age population is more than the non-productive population. Hence, Indonesian government strives to improve the competency of the young generation through a concept or strategy for holistic and integrated human resource development. We have to look at the idea of improving the quality of human resource from the perspective of human capital life cycle. The development of human resource is a continuous process that involves all stages of human life. The government, through comprehensive and integrated intervention, providing various programs and policies in every stage of human life cycle. It ranges from the period of pregnancy to elderly. The key initiative is to create a competent, competitive, and productive workforce. Thus, the young workforce become an advantageous capital for national economic development. Ladies and gentlemen, human capital development is priority for the government of President Joko in second term was in preparing Indonesia golden generating in 2045. effort of carry out to improve the quality of human capital, namely equal distribution of quality education, improvement of science and technology is development, health improvement, and labor reform. Furthermore, in 2022, the government has issued Presidential Regulation number 68 of 2022 concerning revitalization of vocational education and vocational training to create a competent and competitive human resource. The implementation of vocational revitalization is coordinated by the coordinating minister for human development and culture as the chief steering committee. The presidential regulation is intended to prepare competent and competitive workforce and entrepreneurs in accordance with the needs of the industry. Presidential Regulation number 68 of 2022 encourages a change in the paradigm of vocational education and vocational training from supply-oriented to demand-oriented, and prioritize the role of industry and business sector. Improvement in vocational education and training must be carried out through restarting from the curriculum alignment, provision of infrastructure, provision of educators and instructor, provision of access to internship or practices at industry and business sector focus, to institutional accreditation and certification of graded competencies as quality assurance. Distinguished ladies and gentlemen, I would like to express my appreciation to the organizing committee and all participants of this conference. It is a great pleasure for me to be here with all of you. Hopefully, this conference will bring solutions and recommendation toward the progress of green technology and sustainable environment. I encourage Yogyakarta State University to continue to improve its quality, to create innovation and technology toward sustainable environment, and to produce excellent prospective educators. Qualified educators will bring Indonesia to become a developed, independent, and equal with other nations in the world. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much. All participants, ladies and gentlemen, coming up next is the plenary session 1. Two outstanding speakers in their fields will be sharing their ideas with us in this session. They are Professor Zheng Xiao Liu, PhD, from the Department of the Electronic and Computer Engineering, National Taiwan University of Science and Technology, Taiwan. He will be discussing introduction to ORAN and the ML-based traffic steering. The second speaker for today is Professor Dr. Eng Insinyur Didi Nurhadianto, MT, IPU, from the Department of Mechanical Engineering Education, Universitas Negeri Yogyakarta, Indonesia. He will be presenting development of corrugated metal baskets for pipe-to-pipe joints. Chairing this first session is Ibu Yuyun Yulia, MPD, PhD. Ladies and gentlemen, please join me in welcoming Professor Liu and Professor Nur Hadianto. Ibu Yuyun Yulia, MPD, would you please take the floor?
All right, thank you very much. Into minute, check. Is my voice clear enough, everyone?
Yes, Ibu, very clear.
Okay, thank you. Well, like what already the Vice Rector 1, Professor Margana said that this conference is fruitful and like to say thank you very much, representing USD and also as the co-host. And thank you very much also again for the committee. And now in this in Yogyakarta, still cloudy outside, but I believe that we are so happy welcoming these two scholars, brilliant ones, to discuss later on what they already prepared. Well, before we come to the first keynote speaker, I would like to read, let's say, to have a brief introduction about both of, okay, the first one is, my apology if I got mispronounced, Professor Zin Xiu Li, PhD, or Professor Jerry. Are you with us? Yes? Okay. Okay, thank you, Prof. Well, Prof. Jerry is, let's say, scholars, and first one, I would like to highlight his educational qualification, beginning from Bachelor Science in Mathematics and also Master degree in Computer Science from National Taiwan University, Taipei, Taiwan. And then his PhD on computer science from National, sorry again if I got mispronounced, Tsinghua University, Taiwan. All right, and the next one, talking about working experience, Professor Jerry begins his career from 1995 as R&D engineer, and then following, let's say, as the assistant manager industry from Mobitai Communication and Taiwan Mobile, 1997 up to 2007. And I think after working, let's say, in industrial area, then he moves to education, in my opinion, as an assistant professor at the Department of Electronic and Computer Engineering at National Taiwan University of Science and Technology, or NTUST, in 2007, and then becoming associate professor from 2011 to January 2014, and full professor in 2014. Wow, it's cool. And then he got also the position as the chairperson of the Department of Electronic and Computer Engineering from 2017 up to 2020. And now he is a Secretary General of NTUST since February 2021. Well, ladies and gentlemen, regarding his interest, let me read the area that he is interested in, or Professor Jerry likes to discuss heterogeneous network integration, mobile service and platform design, cyber security, machine learning based application development. And wow, it is a role also everyone that regarding publication, Professor Jerry already published 88 index journal papers and then 68 conference papers. Please we welcome Professor Jerry. Prof. Jerry,
Yes.
you are, yes, thank you. You are given about, let's say, 20 to 30 minutes mostly, please.
Okay.
So, yeah, all right. Now the screen is yours. Thank
Okay.
you.
Thank you. Thank you.
So so can you see my screen?
Yep, it's very clear.
Sorry, maybe just let me share it again.
Okay, cool.
Okay.
Yep.
Thanks, Professor Julia's introduction to myself. And it's really great. It's my great honor to be invited to have a talk here. So my name is Zheng Xiuliu. Yes, you can just simply call me Jerry, because when I work in industry, my colleague always like to call me Jerry. So that's why I also encourage you to call me Jerry. Maybe it's much easier to memorize, okay? And yes, I'm the professor in the Department of Electronic Computer Engineering, NTST. And I believe most of you know where Taiwan is, right? So I just like to directly go to my talk today. So the topic I want to share with you is introduction to ORAN and ML-based traffic steering. So here is today's outline. That in the beginning, I just want to give you a brief introduction to the ORAN, and then I will share my experience with you about ML-based traffic steering in ORAN. After that, I will depict the evaluation environment in our lab. And before I give you a brief conclusion, I'd like to show you some evaluation results. So let me just introduce ORAN to you first, even though maybe most of you may not just focus on telecommunications system study, but I just like to give you some concept about this ORAN, and then maybe I will share you some experience for our research. And first, I will give you the current situation about telecom system and what is the ORAN, and could we just have a simple comparison between legacy RAN to the ORAN and its architecture. So the current situation for telecommunications is because, as you may know, I have some working experience in industry, especially in telecom operators. So I have some experience in constructing the mobile networks. So in the past, as you may know, right now, almost every person has his or her own smartphone or a cellular phone. When you want to get when you want to touch some person, like call a phone to your friend or surf the internet, or just like to use instant messenger to contact your friend, the first thing for you is just try to connect to the mobile networks. So when you turn on your smartphone, the first thing is the phone is trying to attach to the network. So the first end, your phone just is touching is radio access network, is so-called RAN, and then it's called core networks. So you can see in the past, the operator need to build up a base station or antenna in the very front end side, and then your phone can be associated with the base station, and then the data or the signal will be converted and then sent back to base station and then the core networks. So in the past, the whole system is highly reliant on some system a vendor like Nokia, Siemens, or Ericsson. So in the past, this vendor just highly dominated the market. And besides, since the system is very close, so maybe you just buy part A from Nokia, but it cannot be used for the system provided by from like Ericsson. So it's quite proprietary. So that's why they can dominate the market. And besides about the heterogeneous situation, when we just move from 2G to 3G and even 4G and even in the future 5G or 6G, there are so many mobile systems. So the operator always face a problem that how to maintain such kind of complicated systems. So normally the operator need to pay high maintenance or upgrade costs to make your service running. So Orange is just proposed to solve such kind of problem. The so-called Orange is Open Radio Access Network. It just features an open interface. And besides, Orange just try to deaggregate the system's function. And then we can try to virtualize these functions onto some servers. As you may know, since Taiwan is well known for its server manufacturing, so if Orange can become true, in the future, such kind of telecom functions can be running on a normal server. So that means you can just buy some commercial of the shared servers to install the telecom services, and even and furthermore, you can even just use the software-defined radio to simply replace the components instead of just paying costly expense to the vendors to upgrade your system. So you can just take a look at this the figure to understand the whole concept. So compare the legacy RAN and ORAN. You can see in the past, legacy RAN will just follow this architecture. So from the very top end, you will use some proprietary hardware, and then you may install some proprietary RAN software, and also its core networks. But when we just use an open RAN, you can see from the very bottom end, you can just use some hardware from different vendors. So in the past, you need to use a proprietary hardware, but right now, if you adopt open RAN technique, you can just use hardware from different vendors. You even can buy some commercial servers instead of some proprietary server to install your system, and then install your open RAN software, then connect to your core networks. So once your system is moving from like 5G beyond 5G to 6G, the simple way to upgrade your system is just replace the open RAN software so that you can just directly go into the telecom service for next stage. So I believe this video can give you the whole concept about why we just use ORAN. So this is the ORAN architecture. I will not go into the details, but I just want to give you a very quick concept. From the very top layer, layer will provide some functions like SMO. SM means system and the maintenance orchestration. You can just regard this part as a operation management, and then you will face a non-real-time rig layer, and then it's a near real-time rig, and then go into CU, central unit, and distribute unit, and then the traditional antenna like remote radio unit. So compared to the new one, you can just have a simple comparison with the legacy one and the new one based on ORAN. So through this figure, I believe you can that can impress your concept about ORAN. Again, from very top, it's SMO, non-real-time RIC, near real-time RIC, and then OCU, ODU, ORU. CU means central unit, DU means distributing unit, and RU means radio unit. That means we just decompose the functions in the base station into 3 parts so that we can deaggregate the functions and then deploy these functions on different servers. So based on this, you can just see that OU, you can just regard it as a front-end radio access point, and your smartphone will just stand here, and you will access ORU, and then go to some other element like DU, CU, and then SMO, and then finally connect to the core network. So this is the basic concept about ORAN. And for the next section, I just want to introduce you the ML-based traffic steering in ORAN. ML means machine learning, because you know right now we just try to apply machine learning techniques to different kinds of applications. Especially, we can just make good use of the property of machine learning so that we can make our application or our system become smarter and more intelligent. So we just use ML, try to help traffic steering in ORAN to make a better decision. So in this section, I will introduce handover and how ML-based TS can be done in ORAN. So about traffic steering, since I know most of the audience maybe come from different territories, so I just want to give you a base concept. Traffic steering is just a function that is responsible for connectivity and mobility management for user equipments. User equipment here means your phone in the mobile networks. And the RAN should be perform handover of the UE to target sales for facilitating seamless connectivity of UE in mobility scenario. So you can just take a look at this slide. You assume you just hold a smartphone, say here. So at the same time, you can receive the signal from different base stations. Like maybe at the same time, you can get the signal from cell C, cell D, and even cell B. Okay, so the core network, the RAN should make a decision when you just move around in the whole area. So RAN should be play a very important role in efficiently using these resources, especially the radio resources. For example, if this cell is very crowded, or you just leaving this cell and go toward to cell A, the RAN should make a decision to move your association to this cell to this cell. So this is a basic concept about traffic steering for UE handover. So how can we just use machine learning techniques to help traffic steering in ORAN? The idea is you can see this is from the very typical ORAN structure. We just add AI or ML aside to help your non-real-time RIC to generate some model, and then just tell your near real-time RIC to configure your base station. So I I just try to explain it in more detailedly that there are two parts. One is non-real-time rig, and the second part is near real-time rig. And for non-real-time rig, here just provide higher layer policies implemented in RAN and or direct connection to RAN nodes. And normally we will use artificial intelligence or machine learning model to provide a smarter decision. And especially this part normally will be done within a control loop that more than 1 second. And for near-time rig, it just provides programmatic control of central units and the distributing units. And its loop normally just costs around 10 milliseconds to 1 second. So after we construct the orange structure and the AI environment, we try to evaluate the concept. So in this subsection, I want to introduce the evaluation architecture and our hardware environment. And since you know right now beyond 5G or even 6G is still unknown, but we try to have some study for beyond 5G and or 6G in advance. So we also have a RAN simulator to simulate the user behavior. And then we just try to use a very simple machine learning method to assist traffic steering to make some decision. And besides, right now, the data we get is just have some basic data. So we also need to label this data because we just use a basic classification tool to classify if the UE need to be handed over. So you can just take a look at this part. This part is just a orange structure, but we just install it on some server with the help of Kubernetes. And then we install near real-time rig here and also near real-time rig here and also near real-time here. And then we try to get some data to install in the database. And this database will provide some basic input like RSRP and physical resource block to the AI or machine learning engine. And then after through some machine learning or model training, then we can install the model which is well trained after the machine learning that install it as a traffic steering app in the near real-time rig. And this is our environment. Totally, we just use 4 machines to install the components I mentioned earlier. That, for example, we just install 1 server for AI machine learning and 2 nodes for the second one is for non-real-time rig, and this node is for near-time real-time rig. And then, as I mentioned, since right now we don't have a physical situation, so we just use simulated environment as an input. So this is a detailed specification for the hardware. And besides, for RAN simulator, we just simulate one situation which is in 2,000 meter times 1,500 meter in a square area. And then we also assume there are 18 cells inside the area. And we also have assumed there are 60 UEs sitting inside the area. And this is the data we get from the simulator, from the connection time, user ID, its coordinates, and its throughput. And from the UE side, and we also can get some data from the sales side, including the PRB, ISRP, ISRQ, and also UE's throughput, its coordinate, and it's also its ID. And we just use a very simple KNN model. Due to the time constraint, I will not go to the detail, but KNN is a very basic machine learning model, training model. So I think it should be a problem for you. But again, you can just replace this part by other machine learning methods, like some other regression model or classification model. About the handover criterion, since you can just take a look at this figure, the horizontal line is about the time, and the vertical axis is about the trigger quantity. So you can see when you move, when the UE is moving, you can find the serving cell, the signal strength from the serving cell will decay. On the other hand, the neighbor cell will increase. So at some certain point, you may make the UE handover. So our strategy is just use neighbor. The criteria is neighbor becomes offset better than the serving node, the serving base station. And then we will ask the UE to be handover to the neighbor cell. So it's the labeling program, because as I told you in the beginning, we just have the data. We don't have the label for handoff or not handoff. So we just use the flow. From the beginning, we will check if the serving signal strength is larger than neighbor's received signal strength. If no, and then we will check if the neighbor node has enough resources. And then if yes, we will label it as a handover case. And this is a KN model. We just try different kind of KN model. For KN1 and KN2, you can see we just consider different input so that we can come out different results. And about the evaluation result, I want to show you, finally, we just integrate the O-RAN fully successfully integrate into our system, and then I will show you some evaluation result. So this figure just show the O-RAN integration result. It's about near real-time rig. So we just developed one app here. You can see there are so many processes inside the system, but this part was developed by ourselves, especially for traffic steering, TS. And because it's a simulation based, so we just try to use E2 agent to set up the E2 node. I mean, for the CU, DU, RU part. And then we just use E2 term to register ran successfully. So I just take a snapshot here for your reference. And about the evaluation result, you can see this is based on different machine learning model, KN1 and KN2. I already told you the difference earlier, but you can find, we just refer to two evaluation metrics. One is drop rate, because you know if the dropping rate is high, that is user will encounter a bad experience, user experience. And the other evaluation metric is handover times. If handover times are too much, that will cause the system burden. So you can see when we take KN1, the drop rate is around 100%. And if we adopt KN2, we can get a 0.1%. About as for handover times, for KN1, the handover time will be less than 300. For KN2, that will less than 1,000. So finally, I will just give you a brief conclusion that Open RAN just feature its openness, the aggregation and virtualization compared to the traditional RAN, especially because in the past, maybe the vendor just dominate the telecom system market. So Open RAN could be a good feature for the latecomer to adapt to control their mobile systems. And AI machine learning can assist traffic steering to optimize the network resources. And even a simple ML, KNN, has been carried out to improve the ML-based traffic steering inside the ORAN. So I already show you the evaluation result in the previous slides. So in the future, because as I told you right now, we just use the simulated environment, but in the future, more end-to-end verification can be done by a real field in addition to a simulated environment. So that's all my presentation today. Thanks for listening. Thank you.
All right, thank you very much, Prof. Jerry. Well, everyone, shall we have our virtual applause for Professor Jerry, please? All right. Well, this is interesting, Prof. Very interesting. Since, let's say, in our mobile phone, I mean my mobile phone, though I already have the term of 5G, but then it comes again to 4G. And now, you are introducing us the term of 6G with perhaps one day with the ORAN, that is open interface and open radio access network. And of course, this one is for customer needs, all right? And also to easier or to cost easier rather than, let's say, the previous one. And also you highlight the term of machine learning or KNN or KNN, in which, let's say, it assists us also, our mobile phone becomes more intelligent.
Yeah.
Okay.
Yeah.
Thank you, Prof.
Thank
Jerry.
Thank you
very much for the very good insight. And well, for all participants, if you would like a question, kindly write the questions on the chat box. And then don't forget to write down your name and also to whom you are addressing the questions, as well as what question or what the question is about. All right. Again, thank you, Prof. Jerry. We are waiting for later on our Q&A or at the end of our first plenary session.
Sure.
Now, thank you, Prof. And we are now coming to the second. Thank you. The second keynote speaker, that is, or he is Professor Dr. Insinyur Didi Nurhadianto, MT IPU. Prof. Didi, are you already with us?
Yes.
Okay, thank you, Prof. Well, allow me please to introduce yourself to the audience in this very good morning. Now, I think outside it's already sunny, just a little bit, yeah? Okay. Prof. Didi, bachelor science, or he was undertaking the bachelor degree from Diponegoro University, Semarang in 1996, and then master degree machine, right, Prof?
Yes.
Yeah.
Yes.
Okay.
Machine Engineering from Institute Technology of 10 November Surabaya in 2001. And then his PhD from Yamaguchi University, Japan, and also engineer professional program from Universitas Negeri Yogyakarta in 2018. Talking about, let's say, qualification of Prof. Didi, he is actively engaged in various associations, I guess. The first one is the member of Association of Indonesian Vocational, and then International Association of Engineers and Consortium Rami Indonesia, or CORI. And also Prof. Didi is a reviewer in journals and international seminar proceedings about, if I count, more or less 11, I guess. And then also he is an editor and also an editor-in-chief for journals, Scopus, and also Sinta and Scopus Index Journal. About the publication, beginning from 2017 up to 2022, Prof. Didi already gained 10 patent title, and then 25 Scopus Index journal papers, and 12 international conference papers, as well as book chapters. Well, everyone, without further ado, I believe also Prof. Didi got another interesting topic. And this morning, he will be exploring his thought on, or the topic entitled Development of Corrugated, sorry if I got mispronounced, corrugated metal gasket for pipe-to-pipe joints. Well, distinguished guests, invited speakers, as well as participants, now we welcome Prof. Didi to share his another brilliant thought. Well, Prof. Didi, the screen is yours, and the same one you got more or less about 20 to 30 minutes. Thank you.
Okay, is it clear for my share screen?
Yes, Bapak, it's
Okay.
very clear.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for invited me to be invited speaker in this conference, international conference. And today I will present my research, our research exactly, development of corrugated metal gaskets for pipe-to-pipe joints. Sorry, my English is Japanese English. So this is maybe not so clear in my English. The outline of this presentation consists of background, developing corrugated metal gasket, and this is a step by step my research, and then conclusion. Background, yeah. Gasket usually put into in between two flank in join pipe to pipe. So pipe to pipe join usually in long pipe or elbow pipe. So you can see this pipe, and then this is gasket. Before corrugated metal gasket, we use asbestos gasket. So this is our design corrugated metal gasket. Asbestos gasket is good gasket to prevent leakage, but it is extremely chemical substance dangerous, causing serious illnesses. So the replacement of asbestos product is expensive, performance is inferior, and have short period of utilization. So it is very urgent to develop new gasket to replace asbestos gasket. So this is development of gasket type, yeah, after asbestos gasket banned. So the material consists of non-metallic, semi-metallic, and metallic. For non-metallic, there is GRP, PTFE. For semi-metallic, graphite. For metallic, flat solid, octagonal, and corrugated. And each material have advantage and disadvantage. So for disadvantage, I'm focused in disadvantage only. PTFE have lack grip resistance and low temperature and low pressure condition. For graphite, have purity, fragility, and storage. And for flat solid metal, it need high axial force, joint relaxation, highly precise tightening procedure. So this is the problem for several material. And for flat shape metal gasket, actually metal gasket flat nearly a characteristic with asbestos. This is a good material, but the problem is for minimal axial force too high. It need 200 MPa. For asbestos just 11. And another graphite resin and gum, it's need withstand pressure resistant very low, and heat resistant also very low. So why this for flat metal gasket have minimal axial force very high? Because the contact stress distributed uniformly. This is for flat shape metal gasket. So we develop a corrugated metal gasket. So for corrugated metal gasket have two portion, which is this is convex portion, two in above and two in below, and then flat portion. This blue line. This is flat portion. For the convex portion can be generated high local contact stress to obtain a low loading metal gasket. The flat portion, this is elastic region, produce the spring effect of metal gasket, and it can be reduce the effect of the loosening of bolt. This is the characteristic of corrugated metal gasket. So this is the another information problem of flat metal gasket. Metal characteristic have the characteristic first hard and second plastic. For hard, is it poor in contact surface on micro level? So this is a contact surface and hard material that the gap between flank and ceiling material, high axial force is required. So tightening force of the early decline. So for plastic characteristic, poor follow up to the flank. When tightening force decrease, elastic plastic deformation and contact stress is extremely slow. Precision tightening management is required. So for the characteristic, so the leak will occur. And then we develop corrugated metal gasket. First, Side et al. Investigated the optimum corrugated metal gasket by simulation and tested using helium leak rate test. So this is the characteristic of corrugated metal gasket. We have overhang OH, pitch one, pitch, yeah, 3 pitch, but same pitch. And then this is the design factor and level, and then the optimized design And this is the helium leak rate for helium leak rate test. And this research justified the helium leak rate, but the leak or not leak not clarified yet. Parameter factor after the gasket performance is contact area, but limit size of contact area for no leak not defined yet. And then this is for next research, the limit size of contact width. So previous study determined the helium leak rate result, but the condition of leak or no leak not defined yet. The study investigated the limit size of contact width for no leak, the contact width obtained by finite element method. To determine leak or no leak, they use water pressure test. To measure helium leak rate, they use helium leak rate test. So this is the device of helium leak water pressure test. And this is the optimum design. And in the left side is helium leak rate test, and the right side is finite element result for contact width. We know that in 1.1 times 10 in the power of 6, there is no leak rate, no leak for water pressure test, and the contact width is about 0.8 millimeter. This is the contact width after we measured the in the experiment. And contact width validation, previous study, the contact width obtained by finite element analysis. This study, the really contact width measured experimentally using Fuji pressure sensitive test. And we focus here for contact width, and we put the pressure sensitive paper between gasket and flank. And we call it, this is convex portion 1, 2, 3, and 4. And the red page appear of pressure sensitive paper after load was removed. The pad was zoomed in using CMOS camera. And this is the simulation result and experiment result. The portion change the displacement of convex portion 1 and 4 higher than convex portion 2 and 3. Contact width for number 1 and 4 experimental tend to be larger than simulation. Convex portion 2 and 3 work primarily to reduce leakage, and convex portion number 1 and number 4 support to realize it. And then we just develop this research. So optimum design of gasket considering plastic contact stress. Design factor inside study was simple. All pitch are same. The design of gasket considering elastic contact stress. This study, its pitch allowed to have a different magnitude. Optimum design of gasket considering elastic and plastic contact stress. So this is our design. OH, pitch 1, pitch 2, and pitch 3, and this is the level. But the simulation just tightening simulation. Optimum design of gasket by using L18 Takuchi method based on contact width. Only modeling tightening process exclude forming effect. So this is the our optimum design in the tabel. So optimum design for plastic design by condition that contact stress below of 400 MPa is deleted because the nominal stress of material is 398.83 MPa. So this is for plastic design, and this is for elastic design in the figure. So the yellow color is plastic design, plastic stress, and blue color is elastic stress. design corrugated metal casket considering forming effect and contact stress effect. So obtaining the optimum design of metal casket using a finite element method based on contact width considering forming effect and contact stress effect. So helium leak rate test of the optimum design metal casket. All previous study, the simulation was with exclude forming effect, but in reality, exclude forming effect. So, so next, our simulation is forming simulation and tightening simulation. So this is the level of corrugated metal casket and the characteristic of corrugated metal casket. Flange and dies were assumed as rigid bodies. Casket material was assumed as deformable body. Using two-dimensional assumption in the axisymmetry model, we use quadrilateral meshing on the casket material. And this is the Taguchi method. The final, the main effect is plotted for a visual inspection of each factor for various levels. And this table is show the optimum descent, our optimum descent. But after we get the optimum descent and by simulation, the final descent shape produce the defect occurred on the radius shape of convex stress. So there is a defect in the convex portion. So we change R to R1 and theta to theta1. Using MSC Mark software analysis found that the lack of difield defect is decreased with increasing the angle inner radius. So the adding 10% of angle showed the best reduction of the lack of difield defect. Okay, so after we added 10%, so there is no defect in the convex portion. And this is the optimum descent. We just change R to R1 and H to H1. So we produce the dies using this parameter to forming material casket to corrugated metal casket. So this is the parameter, final parameter, our final parameter. And we check helium leak rate and for site et al. I mean standard casket. So there is no leakage when axial force 120. But our design, no leakage below the red line. Our design, no leakage in axial force 100 kilonewton and 80 kilonewton. So the helium leak measurement was selected and utilized based on Z2330 and Z2331 standard. And the next research influence of surface roughness of contact stress, contact width, and leak rate. In reality, there is surface roughness of flange and smooth surface of casket because the flange produced by machining. So of course there is surface roughness. Because of surface roughness, when casket contact with flange, there is contact and no contact. This result was used simulation analysis to describe the surface roughness on 25A size metal casket and rock flange. The flange was assumed as a rock surface and put side. And this is the our device to measure surface roughness of flange. And this is the result. For simulation, of course, we include surface roughness in flange and casket material were assumed as deformable bodies. Curve and dies were assumed as rigid bodies. Using two-dimensional assumption in the axisymmetric model, we use quadrilateral meshing for the casket material and flange. The simulation consists of forming simulation and tightening simulation. So this is a forming simulation and tightening simulation. For simulation, we get the contact stress for flank having surface roughness 1.5 micrometer, 2.55 micrometer, and 3.5 micrometer. And the contact stress 1.5 micrometer is higher than 2.5 and 3.5 micrometer. And the contact width also for flank having surface roughness 1.5 micrometer is higher than 2.5 and 3.5 micrometer. And the left side is contact width, and the right side is contact stress. And for helium leak rate test, same as previous study, to obtain helium leak rate quantity for each cascade mode and different surface roughness of cascade. So this also good, I think, for 3.5, 2.5, and 1.5. But for 3.5, there is no leakage after the axial force 100. For 1.5 and 2.5 micrometer, there is no leakage then when axial force 80 kilonewton. Okay. Leakage and contact width. We compare for helium leak rate quantity and contact width. So for no leak rate, no leak. So we get the contact width is 0.2 for 1.5 micrometer and axial force 80. For 2.5 micrometer, axial force 80 kilonewton and contact width 0.195. For 3.5 micrometer, axial force 100 and contact width 0.195. So the minimum contact width that leakage did not occur is 0.195. The real contact width considering surface roughness. So tightening the flank using bolts can cause to high contact stress on the convex portion of the cascade. Groove will be formed in the cascade as illustration of pressure contribution profile to occur between the two surfaces. So this is the real contact width by experiment analysis. We use the digital microscope VH-Z250 series, 500 time magnification. The real contact width can be obtained. So this is the real contact width. Total contact width is sum of the real contact width after the cascade contact width flank. And this is the real contact width by simulation and experiment. So in the left side is simulation result, and the right side is experiment result. For simulation result, we can get elastic contact stress and plastic contact stress. Maybe there is no leakage after if plastic contact stress. And it is a good agreement between simulation and experiment analysis. Contact with for cascade 400 MPa or plastic model is longer than a cascade 0 MPa or elastic model. Contact width for flank having surface roughness 1.5 micrometer is longer than the others. And the last research improving corrugated metal cascade performance through coating process. Cascade made of SUS 3004 still require high tightening force, especially flank surface of 3.5 micrometer and above. The stiffness of the cascade made from SUS 304 is sufficient to provide high contact stress. The cascade surface is coated with a softer material to increase the contact width, and the cascade surface particle will enter and fill the raw flank surface. The coating material is nickel or copper coating through the electroplating process. So this is the characteristic of material for SUS 304, copper, and nickel. And for simulation analysis, we get for copper coating and nickel coating similar. So for contact stress and contact width, almost similar. So we can conclude that we can experimentally to use coating copper and nickel. So this is for forming cascade. This is a cascade, upper dice and lower dice, and material cascade put into upper dice and lower dice. Yeah. This is a cascade. Followed, we use 1,100 kilonewton. To get 1,100 kilonewton, we need 1 minute, and we just hold in 1,100 in 30 seconds, and we replies 3 times for forming process. And this is material cascade, and this is cascade, corrugated metal cascade. This is electroplating process. So in the left side, this is nickel plating, and right side, this is copper plating. But both for plating, we need nickel strike plating. So this is a standard cascade, I mean SUS 304, and this is a copper coating cascade, and this is a nickel coated cascade. For liquid measurement in boiler, we use thermal camera FLIR E4, and left figure is the device in the boiler. And for thermal camera FLIR E4, to measure steam leakage, so we can see this this red color as leakage will occur, and for green color, no leakage. And for water leakage, we use paper, white paper. If there is a droplet, maybe small droplet, even the water will drop to the paper, white paper. So we can measure is it liquid or not liquid. And this is the our research for standard, I mean SUS 304, use in boiler pressure. So for no liquid, we need 120 kilonewton or 100, but not all. But corrugated metal cascade SUS 304 coated nickel and copper, there is no liquid. Even axial force start 40 until 120. For copper also, this is a good performance of corrugated metal cascade. Conclusion, our conclusion is material SUS 304 can use for corrugated metal cascade for surface roughness of flange under 0.5 micrometer. But to produce a flange having surface roughness under 2.5 micrometer is little bit expensive, I think. The parameter design of corrugated metal cascade are contact stress and contact width. Corrugated metal cascade coated nickel or copper increase the performance of cascade. They could stop the leakage of pipe joint that having surface roughness 305 micrometer. Thank you very much.
All right, thank you very much, Prof. Didi. Well, everyone, shall we have our virtual applause, please, for Professor Didi? Cool. All right. Thank you, Prof, for the interesting also insight. In my opinion, since I just realized that we need anyway corrugated metal gasket, especially for pipe to pipe joints, right? And then this one, yeah, of course, we need something like specific treatment for the gasket. So having, you know, the expensive thing. So in this or perhaps pasca pandemic, we need innovation, which is, yeah, of course, should be costlier. All right. Thank you very much, Prof. Didi, for your topic. And everyone, we still have about, I think, more or less 10 minutes. So I invite for, sorry, Prof. Jerry, are you still with us, right, Prof?
Yes.
Okay. Prof. Jerry and Prof. Didi, we would like to invite questions from the audience. I believe they are also eager to understand more about the topic that both of you already delivered. Well, for the first round, let's say, though we have very limited time, everyone, can you please raise your hands up with the reaction, please, just to note that you are asking. All right, thank you. So I can see Papa, hang on. Papa, the committee, can you please spotlight the person who asked? Yeah. Yes, please. Or committee, check, please. Okay, while waiting, Prof. Jerry and Prof. Didi, to me, again, this is a very new thing since, you know, pasca pandemic or post-pandemic, of course, we need to think over and over like what the next will be, what, let's say, breakthrough that we need to do for our green technology or green environment. Now, while waiting, perhaps the question from the audience, I would like to understand, let's say, entitled or this seminar entitled or highlighted on the challenge and also opportunities. So, in your experience, what challenge you find, for example, during or while you are doing your research? And please, Prof. Jerry first, and then come to Prof. Didi. Thank you.
Okay, so during the pandemic, I believe the major challenge for me or for my students is the distance learning, because you know the student cannot just have a face-to-face meeting. So I believe the efficiency in learning become lower. But luckily, we also seen it from the positive side. That I think, as I remember, because you know I also work in industry for around 10 years.
Yeah.
So at that time, we indeed buy some remote meeting equipments, but nobody use. That's just kind of waste, you know. But right now, since we faced the pandemic, we were forced to use such kind of equipment, and since so far, see, even I don't need to go to Indonesia, I still can join the great event.
Yeah.
So I think everything always has its positive side and negative side. But I actually in the past 2 or 3 years, I I didn't have the chance to travel abroad, but now the border is getting open and open again. So I believe sooner or later people can learn the learning or meeting way become more flexible. If I can go somewhere, I still can use. I already get used to the remote meeting. So if I cannot go abroad, I still can use the meeting, the online meeting tool to enjoy some great event. So that's my personal opinion.
All right. So, in other words, let's say, again, because of the pandemic, the COVID-19, and then now we have our post pandemic. Still, we need to have some breakthrough, and then we need to develop more and work more and more. If I'm not mistaken, we got one of the SDGs, Sustainable Development Goals. And then I believe, if not mistaken, the four, yeah, number four, that is quality, let's say, in education, in which, let's say, you are, in this case, focusing on the O-RAN, and it becomes more and more beneficial for, at least mobile persons, or it is at least we can learn anywhere, anytime. Okay.
Yes, correct.
Okay, thank you, Prof. Jerry. Now I invite Prof. Didi. What do you think, Bapak? Yes, please.
Yes. For corrugated metal gasket is replacement asbestos gasket, because production and using asbestos is banned in the world. Start 2008 maybe, and so on. So asbestos gasket totally banned for production and using. So we should change asbestos gasket to another material. So we develop corrugated metal gasket, and we already presented in several industries, PT Cimco and PT in Semarang, I forget, and PT in Jogja also, and they will use corrugated metal gasket to in industries. So in pandemic or post pandemic, they should change asbestos gasket to corrugated metal gasket or another material, because asbestos gasket for production will ban it. So that's my opinion.
Okay, thank you, Prof. Didi. That's very brief explanation. But then again, compared to, for example, asbestos gasket and corrugated metal gasket, in which, let's say, the asbestos is already banned, all right, or prohibited. But then, sorry, what about the price?
Yeah, of course, a price not so different, because material SUS 304 and for coating process not so difficult, I think the price not so different. We not compared yet, but it's not so different.
Okay.
Yeah.
Okay, Prof. Didi. So again, I can highlight from, let's say, the two great speakers this morning in the first plenary session, that in this post-pandemic, of course, breakthrough or innovation, which is badly needed, of course, by scholars. And let's say mahasiswa later on, they still need to go hand in hand together with the docent, with the lecturer. So the innovation will be more and more, in my opinion, improved. Well, thank you, Prof. Didi, and also Prof. Jerry, for the insight from you. And then I can check that there is no questions from the chat box. Am I right?
Yes.
Yes, there is no questions. Yeah. Okay. Thank you very much again to Prof. Jerry and also Prof. Didi for the very good both topics, the excellent ones. And also for me myself, I would like to ask your apology if, for example, my words or my attitude or my, my statements having like inconveniences. Thank you again, Prof. Jerry, Prof. Didi, and Universitas Negeri Yogyakarta. So I believe, let's say, through this kind of conference, so we are having our agile learners, ya, or mahasiswa yang tangguh, gigih begitu, to face our fifth era. Thank you again. Well, everyone, stay healthy and do not forget to
Amin.
be always happy. And love you all. Thank you. And I'll give back to the Master of Ceremony. Thank you.
Yeah.
Thank you.
Thank you, Bu Yuyun, Prof. Jerry.
Thank you.
Thank you.
Ibu Nuni. Cek. Okay. Ibu Nuni, are you with us? Okay. Well, everyone, distinguished guests, invited speakers, as well as the audience. Now, this is the time to have our token appreciation. The first one is that this one is for Prof. Didi. And sorry, committee, can you please, sorry, again, match between Prof. Didi, the screen, please. Committee, yes. Thank you for Prof. Didi. This is the certificate for the invited speaker on the first plenary session.
Yes, thank you.
Thank you, Prof. And then next slide, please, for Professor Jerry. Yes, here we go.
Thank you. Thank you so much.
Thank you, Prof. This is the certificate for or token appreciation. Well, and committee or Ibu Nuni, I'll give it back the screen to you. Oh, okay. This is another one. Bapak Aris Darmansyah Edi Saputra for the keynote speaker. Or in this one is PLT Deputy Bidang Koordinasi Peningkatan Kualitas Pendidikan dan Modernisasi Beragama. Thank you, Bapak Aris, for your topic, delivering or beginning our international conference. Thank you.
Thank you, Ibu Yulia. Heaps of thanks are also addressed to Ibu Yulia, MBD, PhD, for her contribution to the success of this session. All participants, ladies and gentlemen, Now we are in the second session of the plenary session with 3 speakers. The first speaker is Associate Professor Ferry G, PhD, FCILT, FCES from Edith Cowan University, Australia. The title of the presentation is Supply Chain Management and Logistics. The second speaker is Professor Dr. Ing Lee Seon-ha from the Department of Construction and Environmental Engineering, Kongju National University, the Republic of Korea. The title of the presentation is Digital Twin System. The third speaker is Professor Dr. Ing Oliver Mihler from the Institute for Verkehrstematik Technische Universität Dresden, Germany. And he will be discussing changes in engineering or vocational education theory to practice in the context of the connected driving of cars. Dr. Phil Insinyur Didi Haryanto, MD, will be chairing this session. Dr. Haryanto, the floor is yours.
Yeah, thank you. Thank you very much, Miss Nuni. So is my office audible? Okay. Good morning, ladies and gentlemen. Good morning, all participants. And we are now in the second plenary session. My name is Didi Arianto. I am from Universitas Negeri Yogyakarta, and I will be the moderator in this session. The theme of this year conference is post-pandemic challenges and opportunities on green technology and engineering. And our university, as one of the prominent universities in Indonesia, wants to provide a positive contribution for that through this conference. Therefore, we have right now 3 distinguished speakers in these sessions. Wait a minute.
So, yeah. So we have 3 distinguished speakers in these sessions, and I would like to introduce the first one is Associate Professor Ferry G, PhD. He is from the School of Business and Law, Edith Cowan University, Australia. Are you with us right now, Professor Ferry? Not yet. Okay. And the second, we have here Professor Dr. Ing Lee Seon-ha from the Department of Construction and Environmental Engineering, Kongju National University, Republic of Korea.
Hi.
Hello, Professor Lee.
Hi.
Okay. Are you with us right now? Professor Lee?
Okay. Hello.
Okay. Okay, hello. Thank you. Yeah, it is nice to meet you, Professor Lee.
Good.
And we have the third one, the last but not the least, Professor Dr. Ing Oliver Mihler from the Institute for Verkehrstematik, TU Dresden, Germany. Professor Mihler, are you with us?
Can you hear me? Hello?
Okay, Professor Oliver
Yes.
Mihler.
I have a little problem with my Wi-Fi connection, and so I have in this time no video.
Okay, guten Morgen, Professor Mihler. Guten Morgen.
Guten Morgen, ja. Dankeschön.
Ja, ja, wie geht es Ihnen? Alles gut?
Yes, I'm feeling good.
Okay, danke.
A little bad time for me. It's 5 a.m. and I'm in a hotel.
Ja, ja.
Exclusive for you.
Okay, thank you. Okay.
Sie
And
sprechen ja ganz gut Deutsch.
Ja.
yeah,
Okay.
yeah, in Beans, ich spreche Deutsch.
Ich auch.
Okay. Yeah, Dankeschön. And this session will be divided into two parts. The first part is presentation from the distinguished three speakers, and each speaker may have in between 20 and 30 minutes. And then after three speakers have presented their topics, we are going to the second part, discussion and question and answers. Okay, we are going now to the first speaker because Professor Felici is not with us right now. We are going to the second speaker from Professor Lee. Professor Lee, are you ready right now?
Yeah, I'm ready. Give a presentation. The second one, yeah.
So,
I'm the
Professor Lee, wait a minute. Professor Lee will talk about the digital traffic platform, right?
Okay, thank you.
Okay, thank you. Yeah, the time screen is yours.
이거 올려. 이거 넣으면. 영상. 올라오면 돼. 이거 데스크탑 원하는 사람 누구냐? 뭔데? So sorry for the delay. Just a moment, please. 왜안 되냐, 뭐냐?
So while we are waiting for the Professor Lee to
Yeah, just a moment, please.
yeah, it's okay. Yeah, I would like to introduce Professor Lee here. Okay, already.
Can you see my screen?
Yeah, Professor Lee, it is quite clear right now.
Okay, good.
You may start your presentation. Yeah.
Senang bertemu dengan Anda.
Ya, terima kasih, Professor Lee.
My name is Zeonari at Gwangju University. As you introduced, same time I'm the president of the Korean Society of Transportation. So today I will present the digital traffic platform using PTB software. So at first I will show the 4 minutes long videos, and then after I will explain the details about our platform. Please enjoy our videos, 4 minutes long.
We cannot hear this the sound, Professor Lee.
So I explain after the showing the video.
Okay.
Please enjoy the video first, yeah?
Yeah, but we cannot hear the sound of the video.
So it's muted, yeah. There are no background sound, sorry.
Okay, okay, thank you.
Good. So as you saw my video, this platform is actually for the local government at the city level. So I try to provide the local officer of the local government to forecast the traffic demand and for the traffic management and signal optimization. So this is a comprehensive platform. And this is the architecture of my platform. The left side is the traffic demand parts. And this is the public transit parts. And actually, I'm using 4 simulation model. I don't know if you are familiar with the microscopic model VSIM or macroscopic model VZoom. And there are also a public transit model, Vision POT. And I am using also for the traffic signal control system, LISA software also. So I combine the 4 simulation tools for establish a comprehensive transportation analysis model for the city level. And to build the traffic demand model, we need a socioeconomic data for every traffic cell. And for this purpose, we need a socio-economic data. And the Ministry of Transportation in Korea provide us the this kind of land use data for every block. And the color differentiate from the land use classification, and you can see also the size of the land use data. And based on that, I build the traffic demand model. At first, with the network, I can analyze the whole the things of that, and if this is the travel demand model in area Seoul at the hourly time interval. You can see the traffic volume for every hours. And this is the microscopic model using vSIM. Actually, this big size is quite difficult to import the traffic volume for every single intersection, but I try to connect the macroscopic model Visum with the microscopic model vSIM, so I can import all the traffic demand data with network and traffic volume into the vSIM directly. So I can build this kind of big size microscopic simulation model. It's city Ulsan, and in detail we can use this vSIM model using the how we can build the bus stop or railway station and so on. This is not only the video, but the real situation. And this is the microscopic simulation model for city Daejeon, and you see the here background buildings. So also the Minister of Transportation in Korea provide us a virtual world information, so we can easily import the background buildings. So it's also based on vSIM microscopic model imported from the Visum demand model. So we can establish that kind of big size traffic simulation model. And this is for the so we can use this vSIM model. We can forecast if there are any kind of accident like here. So because of the traffic accident, 2 of 3 lanes are blocked. Then we can forecast how long is the queue length, and then after we can take out countermeasure. We can divert the traffic volume using this kind of VMS, or we can readjust the traffic signal system. And this is the public transit model for the Jeju Island. And this is the pedestrian simulation model. And actually it is useful for the design the railway station or transfer point. So we can use this kind of a bespoke model. The color of bottom means the density, pedestrian density. So we can reorganize the passes, and for the And this is also a bespoke model. We can directly import this kind of a building information system directly into the bespoke model. And based on a VC model, we can also optimize the traffic signal model. You see here Vistro. This is a kind of a measoscopic model that is for signal optimization or traffic impact analysis. So we can optimize the green band. And this is a signal optimization platform. So we built by ourselves and using BSIM model, and we can select any kind of traffic corridor which should be coordinated or optimized. And this is the priority signal coordination. If there are some fires or accidents, so the emergency car can go through across the traffic signal. And there are also algorithms for that. And if the area is very congested situation, so there are a kind of a balance model. And this is the user interface using the smart signal. And this is the traffic impact analysis. And this is for the office for the local governments. It is quite difficult if they are using this kind of platform. So we make a simple user interface for the local government. They are easily using our model. And from all the results of our software, we can present to the client or decision makers that kind of presentation material. And this is the whole Seoul area public transit. Every point means the transit line, and the red one is the high-speed railway, and so on. So this is the TOMS model, Traffic Online and Monitoring Management System, focused for the local governments. So I think that I waste my time already. But if there are any questions after my presentation, so I will try to answer the questions. Thank you very much. Hi, hello.
Yeah.
Yeah, I'm finished with my presentation.
Okay, thank you. Yeah, thank you for your presentation, Professor Lee. It is quite interesting developing the 2D and 3D digital traffic platform to support the traffic management system. And Professor Lee also saw us in the implementation of his digital twin platform in various cities in Korea. Okay. Thank you very much, Professor Lee.
My pleasure.
And I'm going to go to the next speaker right now. We have already here Professor Michler. With us, Professor Michler. No, not yet. Okay, yeah. Professor Ferry. Okay, video. Yeah. Okay, Professor Ferry and Professor Mikkel right now not joining with us, but I'm sure they will be joining us in the discussion sessions. And because Professor Ferry is already provide the video presentation with us right now, and yeah, Professor Ferry plus for the video presentation, please. For the all participants, you may watch and listen to his presentations of Professor Ferry. Yeah, the title of Professor Ferry's speech, Supply Chain Sustainability Management in the New Normal.
In the area of supply chain and logistic management. I'm just giving you my email and my WhatsApp's address. You can be able to discuss or have any question or to have a research collaboration with me. Please reach me through the WhatsApps or email address. Okay, so this is my background. I have published more than 55 referee journal articles in the last 5 years, including 31 articles in Q1 and 23 articles in Q2, as well as 10 referee conference papers. In addition, I also have received research grants or awards adding up to over 1.85 million between 2010 and 2022. As you know, I'm currently in fellow Charter of Institute Logistic Transport, FCILT, as well as Steering Committee of Supply Chain and Logistic Association of Australia in Western Australia, and also the Secretary to the Charter Institute Logistic Transport Western Australia Committee. This is the list of my research project, research grants. Currently, I'm doing project Digital Competencies Framework for the Australia Energy Industry. This project will be finished in 2024. And the project has just finished early this year. Is a business continuity and resilience, capacity building and upskilling post-COVID-19, funded by Department of Job, Tourism, Science and Innovation. The rest of the papers, projects already published in the top tier journals, such as the Waste Project and the Smart City Project, as well as planning intermodal and general logistic infrastructure for the future needs of Perth. Now, everybody knows what is supply chain. Supply chain is a management of all activities that facilitate the fulfillment of a customer's order for a manufactured goods in order to achieve customer satisfaction at a reasonable cost. Supply chain needs several operational activities. For example, we're working very closely with suppliers, vendors, which they provide raw material components, spare part to manufacturer to the factories. And then the next function, operation activity, what we call purchasing or procurement, transportation, demand forecasting, and as well as inventory management, managing risks and uncertainty that may disrupt the supply chain. As you know, in the last 26 months, we have a problem in terms of supply chain disruption, demand shocks and empty shelves in the supermarket in certain products due to COVID-19 or pandemics. This is what we call supply chain risk and uncertainty. And then measuring supply chain performance. I have 5 papers published in the top-tier journal about supply chain performance in the Australia beef industry and supply chain performance in the Australia red meat industry. And then next one is ensuring sustainability. This is the topic for my presentation about sustainability supply chain in the new normal. And then this is a supply chain structure. As you can see, for a firm, we have cereal manufacturer. And then you can see we have upstream, first tier, which is flour processor, corrugated manufacturer, polyethylene bag manufacturer. And second tier, we have a farmer, plumber, provider, chemical processor. And the third tier in the upstream supply chain is oil company and forest. And then for downstream, in the first tier, we have grocery distributor. A second tier, we have retail, grocery, supermarket, and the third tier is a consumer. So supply chain in the cereal manufacturing is a product and services from upstream to downstream, also downstream back to the upstream. This is what we call reverse logistics. And then supply chain, not only product and services, but also the information planning across the supply chain or end-to-end supply chain. So I would like to share video presentation, what we can see, what we can learn, supply chain in the Australia largest supermarket like Coles and Woolworths. And then I would like to share video presentation about Coles supermarket in Australia.
Coles has been part of the Australian retail environment for over 100 years. Starting from a single store on Smith Street in Collingwood in 1914, we're now transformed into the nation's #1 supermarket with over 750 supermarkets, 800 liquor stores and 600 convenience stores. With a workforce of over 100,000 nationally, it's quite a big operation, as you can imagine, to move all of these products around the country. We have a distribution centre network of 25 DCs, which we have in every state with the exception of the Northern Territory, which move millions and millions of pallets every year and billions of individual items into store for sales to our customers. As you can imagine, on a business as large as Coles, we rely heavily on our business-to-business or B2B e-commerce. We use this in conjunction with our partners at GS1. We use a whole bunch of their tools, so our trade identification numbers, so all of the barcoding, etc., that you see, not only on the individual items you'll buy at store, but on the master cartons that move through our DCs on pallets, which allow us to efficiently and easily track everything moving through our system. This has real advantages for us at Coles in the fact that it allows us to utilise such things as the electronic data interface, and in particular the advanced shipping notices, ASNs. The real benefit of this is it allows our suppliers to send through to us in advance of all of the shipments they're sending into our DCs, which once the DC are aware of that and is coming in, allows them for fast and efficient receipt into the DC and further put away. And with millions and millions of cartons and pallets passing through our network every year, the ability to put these to bed quickly into the DC is really, really key. Another great feature from GS1 is their recall tool. It is a really fast and efficient tool that allows us to send an email through the system directly to all the distribution centers and stores and track where every single item that is under a recall notice is in our network, and it can be pulled as quickly as 30 minutes after we've got notification of a recall or withdrawal notice.
Okay, so if you look at Coles supermarket, as you know, Coles supermarket is the largest supermarket in Australia. It has more than 700 stores in the country. And, you know, Coles has worked very closely with GS1, which means that they're helping with the barcoding and scanning technology to manage the inventory, to manage the supply chains, you know, to ensure the product actually, you know, on the shelf, for example, and customer can get product very quickly in the supermarket. So now this slide, we talk about the supply chain evolution or supply chain history. So if you look at, you know, up to 1960s, so all activity fragmentations, it meaning that's demand forecasting, purchasing, requirement planning, production planning, inventory, warehousing, packaging, until finance, sales, marketing. So up to 1960s, more activity fragmentation. So early 1980s, so that's we have the integrated logistics. So the purchasing material management consisting of demand purchasing, production planning, warehousing, you know, material handling and packaging. And then we have physical distribution, including finished good inventory, distribution planning, order processing, transport, and customer service. And then in early 1990s, so pretty much 32 years, that supply chain was born. So supply chain management was born in 1990s. So that, you know, the history of supply chain. Now, this is, I'm talking about sustainable supply chain management. The environmental aspect has integrated together with the traditional supply chain practices, developing into the concept of sustainable supply chain management. Sustainable supply chain is grounded upon the traditional concept supply chain management. It's been a while, nearly 12 years now. Sustainability is defined as the ability to utilize resources to meet the present demands and needs without compromising resources for the future generation. The underlying concept of sustainability is the notion of environmental, economic, and social dimension, also with no triple bottom line. And what is sustainable supply chain management? It is the set of managerial practices that involve the flow of information and capitals among organizations along the supply chain, considering economic, environmental, and social requirement in all stages of the chain, including product life cycle. So if you look at the literature review in a sustainable supply chain, there are so many influential factors that contribute to the adoption of supply chain sustainability, reflected by various sustainable supply chain literature, manager beliefs, environmental pressure, supply chain economic pressure, market influence, customer influence, community influence, government pressure, technological capability, strategic collaboration, and internal strategy. So they are most common factor to engage in sustainable supply chain management. Now, extensive belief and incentive of the owner, of the founder of the organization can affect the intention to adopt sustainable supply chain. So it's been a while, it's about like 14, 15 years now. And then environmental innovation. So, you know, about like, 20 years now in terms of the focal manager interests. And there are many reasons that may persuade the organization to participate in sustainable supply chains, such as the decision to strengthen the product life cycle, improving production, It is crucial to optimize production while producing little environmental impact. This may lead to efficiency, intensive strategy, reducing unnecessary waste. Okay, so if you look at the literature, the methodology, I'm doing systematic literature review. What is systematic literature review? I think most of you know that systematic literature review, we simply enter the keyword such as sustainable supply chain and big data analytics. We have so many different database like Business Source, Premier, EBSCO, Emerald Insight, Science Direct, Scopus, and Springer, and IEEE Explore, for example. So the process of systematic literature review is collection of literature, and we know the literature, comprehend the literature, apply, analyze the literature, and evaluate the literature, including output. So if we talk about sustainable supply chain in relation to big data analytics, so after I'm doing the literature review, a systematic literature review to investigate the application of big data analytics in sustainable supply chain, the result indicated that big data analytic techniques usually use the predictive and prescriptive approaches rather than descriptive approaches. So 4 years ago, Barbosa mentioned that in their research. Now, to identify the effect of big data and predictive analysis to aspects of sustainability, including environmental and social aspect. So Dubey and his team 3 years ago mentioned that in the paper about that is environmental and social aspect, implementing big data and predictive analysis in the sustainable supply chain. Now, talking about the research method, a multi-objective optimization model for green supply chain using big data analytics. They consider 3 different scenarios for optimizing the inherent risk associated with hazardous materials, carbon emission, and overall cost. They utilize a big data approach to acquire data and manage their quality. Now, problem and challenges arising due to big data in the context of environmental performance evaluation, along with summarizing latest development in environmental management based on big data technologies. So that's according to Song in 2017. Now, in terms of theories, so if you publish in the top tier journals, a lot of journals expect the papers, what theory underpinning in your paper, in your research. So in the sustainable supply chain and the big data analytics supply chain management context, we have so many different types of theoretical underpinnings, such as a complexity theory, transaction costs, resource dependence theory, resource-based view, social network, institution theory, stakeholder, and ecological modernization theory. So if you publish in the top tier journals such as International Journal of Logistic Management or Supply Chain Management and International Journal, if you can see, the structure of the paper, they have an introduction, right? And you got literature. And then if you develop the hypothesis development, you need to think about what theory you're using for your research. So you need to have a section about theoretical underpinning or theoretical framework. And then start with the methodology, data, finding, or result, and the discussion and conclusion. So this slide, I would like to talk about how can this help my business in post-COVID. So I would like to spend a little bit more time about this. First of all, we need to restructure your supply chain framework, in particular for post-COVID-19 or in the new era. So before COVID and post-COVID, your supply chain structure, might be different. So you need to restructure your supply chain framework. Why? Because maybe your suppliers no longer does not exist anymore, or maybe your third-party logistic providers or your major customers, and you need to restructure your supply chain framework. And then you build a supply chain localization, and then private product services to appeal to local markets, introduce supply chain digitalization transformation or technology like Coles, working very closely with GS1 to introduce digitalization, barcoding to reduce dependency in human labor, and rely on supply chain relationship, working very closely with suppliers, vendors, third-party logistic providers, and introduce lean, which means that cost reduction strategy, agility, quick response for any changes and uncertainties. And we introduce lean and agility. This is what we call the agile. We work together with other local businesses to increase demand and to reach demand, investing locally, upskilling local staff to reduce reliance on overseas markets, and business continuity planning, introduce supply chain adaptation, preparedness, recovery, and sustainability. Now, future research in sustainability supply chain. So I just want to share with you all sustainability supply chain in relation to supplier relationship management, and sustainability in relation to a network design, sustainability supply chain in relation to procurement, sustainability supply chain in relation to cyber security, and agile supply chain sustainability, lean thinking supply chain sustainability. Lean plus agile, that's what we call lean agile supply chain sustainability. And then we have a big data analytics sustainable supply chain. Now, future research in the traditional supply chain management. This is, I mentioned, is still a lot more scholars still doing traditional supply chain practices like, quality, project management, strategic supply chain, warehouse management system, transportation management system, and logistic information system, and supply chain management industry 4.0, right? Or blockchain, for example, Internet of Things, for example, right? So that's the future research in supply chain management. Now, I just want to give you, this is the list of my publication related to sustainability supply chain. So majority I published in the Q1, so all of you be able to get access my papers, and you'll be able to read papers like supply chain insight from social media user respond to panic buying during COVID-19, the herd mentality. And this paper has been published recently in Asia Pacific Journal of Marketing and Logistics. So in 2022, right? And then the other one is social media user perspective on the supply chain, positivity amongst negative during COVID-19, panic buying in Australia. International Journal of Agile System and Management is in the Science publisher, right? And this is the list of publication related supply chain and logistic management. That's a good example for you if you want to read my research, my papers, the supply chain and logistic management. As well as I published a lot of paper in halal supply chain, like halal accreditation, certification in a non-Muslim country setting inside from Australia, halal meat supply chain. This is International Journal of Supply Chain Management in 2019, right? And then I published with my colleague, at University of Diponegoro, a paper in supply chain performance flexibility in the Australia beef industry. That's a Q1 in the 2016. Right. So that's the rest of the papers also in a halal risk mitigation in Australia, Indonesia, red meat supply chain in Journal of Islamic Marketing in 2018. And then you'll be able to download that paper as well to read about halal risk mitigation in Australia, Indonesia, red meat supply chain. So thank you very much indeed for listening. Before I just close my presentation, I would like to share one more video about Woolworth supply chain. So you'll be able to listen about Woolworth supply chain.
With Google Ads, your ads can reach people who are looking to buy exactly what you sell. We saw initial success by investing $25 a day.
My name's Paul Turner. I'm the Produce Operations Manager in Western Australia. It's my job to liaise with the operations and the buying team to ensure that we get the produce to our customers on time and the freshest possible way we can. A lot of the stock we receive will arrive sometime between 4 o'clock in the morning and 10 o'clock in the morning, and we'll have that dispatched to our stores for sale up until 10 o'clock the same day. On an average week, we'll shift 170,000 cartons of produce for our DC, and this goes up at peak times of the year like Christmas and Easter.
I'm Jim Trandos from Trandos Farms. Trandos Farms is a third generation company. It goes back to 1939. Trandos Farms supplies sweet corn and beans to Woolworths. I spend a lot of time in stores. I like to go and have a look at the product. I like to walk in stores, see what consumers are after. If someone picks a product and puts it back down, I ask them the question, why did you put that product back down? What don't you like about it? What do you think we can improve on?
We see Jim and the likes of Jim really getting out there. They love their product, they love what they do, and they especially love when they come into stores and see how much the consumers enjoy their end product.
There's been some great partnerships in regards to Woolworths in recent times, especially the last couple of years with some great promotions of product. It's very important when they get behind the product and we get behind them and supply a good product.
The key importance to us is to make sure that we have safe, fresh food for our customers. To enable this, all our fresh trade partners must be WQA qualified. What that means is they have certification for Woolworths quality assurance standards. This involves a comprehensive range of tests that they must pass in order to supply us with fresh, safe food.
Trandos Farms is an in-house consultant that does our QA. Some of the benefits you get with the QA system is good traceability of your products, where they've come from. And if you marry that in with your accounting system, you can get some pretty positive results.
It's just fantastic to be able to get out and visit the growers and to see where the product comes from. There's a lot of hard work goes into actually getting the product onto our shelves, and I know that our farmers take great pride and care in what it is that they do to make sure that they work with us to deliver the freshest possible produce that the Australian consumer can have.
Okay, so as you can see, Woolworths, Coles, and supply chain in the largest supermarket in Australia, like Woolworths, the fresh food people. The thing is for Woolworths, for the supply chain introduced for fresh food people to maintain quality, fresh, selling fresh produce like, fruits and vegetables to the customers to ensure they have a very high quality product to the customers, to work very closely with suppliers, growers, producers, this is something we can see how we work very closely with suppliers, producers, like what we can learn from Woolworths, right? Okay, so thank you so much for listening. I would like to say congratulations to the conference, the number 8 International Conference on Technology and Vocational Teachers, right? What we call ICTVT in 2022. I wish all the best, and please, if you have any questions and comments, I'm more than happy to answer questions and comments in during discussion session. Right? All the best to you. Thanks so much, and I would like to say all the best to you all, and then please all the best to you all, and then good luck and enjoy for the conference. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Ferry. Right, Professor Ferry join us now, but we have still another speaker here from Germany, and please, Professor Ferry, to stay here until we have a discussion session. But we have still another speaker here from Germany, and Professor Dr. Ing Oliver Michler. He will talk about the changes in engineering or vocational education from theory to practice in the context of connected driving of cars. And unfortunately, he cannot join with us right now, but he already prepared for the video conference as well. And for the participant, you may watch and listen to the video presentation of Professor Michler. The committee? Yeah. Okay.
My name is Oliver Michler. Welcome to my keynote presentation. The topic of my keynote presentation is change in engineering or vocational education from theory to practice in the context of connected driving of cars. Now you can see in the next slide the agenda. What will we do in the agenda? The first part is named Introduction, Traffic Telematics. The second part is Digitization in Transport Service. The third part is Connected Technology in the context of teaching. And last but not least, we will finish with the part of confusion. Let us at first discuss some details about the Technical University of Dresden or the location of Dresden, because Dresden is the capital of Saxony and is located in Germany, and Germany is located in Europe. You can see it in the blue field. And in the special part from this, you can see that Dresden, at the Technical University, is located on the east side, what we say, of Germany, near Berlin. And some dates of the capital, Saxony, or we have about 500 inhabitants, is a very famous city of culture and science. And typically, we have more about 40,000 students in 7 universities and colleges. Yeah? Our faculty is named Faculty of Transport and Traffic Science. It's a very strong interdisciplinary competence center for transportation science, because we have different institutes based off traffic carriers, for instance, Sensei's Institute of Automobile Engineering, railway vehicles, for instance, public transport, for instance, logistic aviation, and transport and economics, and so on. My institute, in which are, could you see, located my professorship, is the Institute of Traffic Telematics. The short word is ITVS, Informationstechnik für Verkehrssysteme in German, or ITS systems for traffic processes. But we have a strongly connected things, and of the scientific part, of the education part, with market focus, transportation mobility, and very famous or interested for us is that we have a strong change in the education, the transportation economy, and the transportation engineering, because based of the new mobility strategy, of the new mobility acts and so on, now we're in the process to change the education things in our faculty, in our education process. What this means with traffic telematic, what is traffic science, what also studying transportation things in this part. Because on the left side, you can see we have typical the mode of road user, the driving mode user, from the inter-technology perspective of the one side, or also intermodal perspective of the other side. Because all transport things typically use vehicles, for instance, automobile, train, aircraft, and ship, and the vehicle drive or have to drive on what would you say of a construction unit. The construction unit is a track. The track is then named the road, the rail, the air, and the water. No? And if you make some things in the part of testing, of the development, in the part of scientific and so on, then you can see here some pictures, automotive part, aircraft part, for instance, railway part, or for the shipping part, which we use with different measurement cars, with different measurement vehicles, and with different measurement vehicles. No? Typical for students, for the process, for the development, and what is with scientists things are signal and data processing things. Then we have to use communication, localization, tracking, and state detection. And all things, all objects, all persons have to do in the future to make connected with another. This is the main part, and this is a part and topic of my presentation. What is the slogan for this? Because everything moves, everything is connected. No? It's beginning from the public transport system. No? The bus is connected with the people. The people have your smartphone. The people, the bus have connected with the timetable of the bus times, with stopping and going and so on. No? The same for the tram. No? The same for the bicycle, for instance, the same for the electric car and so on, no? For fast trains, for instance, no? and so on. No? Because all things for a good mobility, for effective mobility, for a good feeling of mobility, can you use if the objectives and processes are connected with another. No? And the typical, and what would you say, very real-time thing or the Corona app, the Corona risk app, for instance. The Corona risk app can only work, can only functionable if you have a connecting between different apps, different mobile phones, and so on. And so you can see in a Corona app on the left side, can only use or is only usable and functionable if you have connected things with another. And this is a topic for the presentation, but it's a topic for student education, is a topic for research things and for scientific processing. But the next part is we have the urbanization and the development in these things, because the urban population will grow from 3.5 billion to over 5 billion, and people and population, people and so on, up to 2030, and give another number of persons. No? The next is that we have the gross domestic product is a strong growth with it up to 2025, yeah, 75% more. And today we have greenhouse gas emission come from transportation and so on at a very high participant and very high percent and very hard contents for 25%. Yeah? And so we have many things to do to make the environment, to make the mobility, make the transportation, to make the traffic things with more green aspects to get a lower number of percent for greenhouse gases, for instance. At the moment, we have many important mobility trends. For instance, real-time mobility marketplaces. For instance, the Corona app has pandemic detection, for instance, health detection, for instance. No? Digitization between different traffic areas, between different objects. No? Is the tank room, is it a bicycle, is it a car, is it the housing, for instance, and so on. No? And the decarbonization are the same. No? These are many trends. The electromobility is a very high dynamic trend that more and more electromobility processes will come in, or processes will come in our normal living. I think it's clear. No? We have new transport objects. For instance, to transport for goods, the drone. You can see here many new forms of good transport. We have additional transport features, more comfortable, more multimedia, and so on, more universal connected things. You have the possibility to address many customer needs from the house, in the work, in the free time, in the holidays, and so on. And last but not least, a very strong trend is autonomous driving. It's autonomous driving over all traffic carriers. Is it the car, the self-driving car? Is it the self-driving public transport object, or it's a vehicle? Is it autonomous driving of shipping, for instance? Is it autonomous driving of the plane and the airplane and so on? Because autonomous driving have strong influence over all processes, over all traffic carriers, over all vehicles in our model. From this part, we get newer product and service innovations. New cars, new electrical autonomous connected things. And this will do step by step from the connected IT systems up to new business model innovation, more on-demand shared cars, and so on. And for this processes, you need things, you need participants, you need scientific disciplines, for instance, communication, ranging, localization, tracking, and sensing of one partner. You need software-defined radio, because a universal communication unit, which you can program it with the right software to do all things which I do, because sometimes it's a receiver, sometimes it's a transmitter, sometimes it's a localization transceiver, sometimes it's a multimedia music transmitter, and so on. All things are possible only in software. This is named software-defined radio. No? Yeah. And these things, because with respect to real-time communication, localization, tracking, and sensing, and so on, give us new business model, new innovation, new market chances to do more and more in this part. No? What is the following effect from this? Because if you have a universal electronic unit, software-defined radio system which can do communication, ranging, localization, sensor over one electronic device, then you have lower energy. You need lower energy. You need lower details, lower parts of electronics. The reliability is grow. The maintenance, for instance, is grow, and so on. Because many new aspects in this part, which give us in the next part product and service innovations. Yes, and this on-demand service, shared services, or services, multimedia services, personalized vehicle sharing, autonomous driving services, and so on. These are the typical business model innovation in the next time, which have a strong basic, a strong groundable from the connected things over all objects. Let us make a little look in the history. Because if we take only the automobile production, the automobile topic, we have the automobile generation 1.0 is the individual production. One automobile, one part, one object, one vehicle, or in the production process. The automobile generation 2.0, or is the so-called mass production. because many vehicles are in a line, many vehicles are in a production process, in a sequential process, for instance. The automobile process 3.0 is then you have automation and robotics inside, because not enough manual works, more robot automation works in the production process. And last but not least, in the automobile 4.0, then you use in the production process, in the maintenance process, in the driving process, in the signal processing, you take IoT as Internet of Things, big data, artificial intelligence, machine learning, and so on. Very, what would you see, complex, but very efficient informatic modules to do. This is a part which now reflected in the number of agenda number 3 to other visit of the education process, because in the older process, automobile 1.0, 1.2.0, yeah, you have typical only normal academic tools. You have the lecture with the blackboard, you have access with the blackboard, and this are the training and the education method. Step by step in the newer process, for instance, the generation 3.0, 4.0, yeah, you need software programs, simulation programs, you need lab equipment, modeling equipment, a small light model of the vehicle, for instance, a small light model of the signal of the control of the sensor platform and so on. And so you have other academic tools in the newer generation, lectures, for instance, PPT slides, videos, you have exercise, you have digital simulation and the field test and real data trainings. These are the new topics or the new basics of the education process. And this is necessary over all what we think technology parts of modern mobility, of modern transport processes, because if you discuss traffic telematics, yeah, you have a categorization for things, yeah, then you have many painfully but necessary communication systems. Yeah? There's also blue systems, wireless vehicle communication, for instance, the mobile communication, for instance, and digital broadcast system communication. Yeah? You have environment detecting signals, localization, positioning signals. In the other color, the orange color, GNSS, GPS, GNSS, and little navigation systems. Yeah? You have radar systems, for instance. Yeah? You have LiDAR as optical systems with LiDAR or depth camera systems and so on. Yeah? Then you have to use informatic experts. We have all sensors give us or to give you signals, output signals, raw data signals, and only this you can only make output. You can only make state estimation, for instance. For if you for this you have to use multi-sensor data fusion or data fusion, because all data are connected and give a common output signal, a common output state system, which is named as a multi-sensor data fusion. And then you have to do the signals, the locations, the communication data, and so on part dereferencing. You have a map, but if only you can use the map if you take it in a dereferencing process. These are things which we can do for this, and so we have to use from the theory of the one side, yeah, in all this technology, step by step, to go into practice. Practice this live sensors on the car, real sensor on the car, with a real car. Yeah? You can see here a measurement car for autonomous driving, for instance. Yeah? And so we need for the course topics strong telematic specialization over modern training aspects. Yeah? Here you can see some example, because strong telematic specialization, we have modules or lectures which is named next generation mobile communication. real-time signal processing, machine learning systems, traffic sensor systems, robust control, safety and security algorithm, or descriptive statistic mathematics. This is all the specialization topics or the courses, and the tools, academic tools, this are lectures, exercise, digital simulation, the raw data mining, real field excursions, professional automotive companies excursion. These things are necessary to learn, to train, to make a training aspect, or to make educational input for students with the new technology parts around or mobility or transportation process. And the tools, software tools, programming tools, for instance, and so on. And the tools give us from the informatic part, PC-based, laptop-based, processing-based, the output, or sometimes in the lab, you have a sensor in the lab, you have a sensor on the car, for instance, and you have a simulation equipment which you can do, collect the sensor signals and give the output of the surface or of the output device. So here can you see some components, teaching components, which is named as the changing of the didactic and methodology. Links is typical. You have a classroom. You have what would you say, a table, whiteboard table, and for the theoretical aspect, for the training aspect, for calculation, for what would you say, for discussion on. And step by step in the newer academic aspects, you have to need simulation areas. Yeah? You have a field test areas with students, because the students have to drive inside the car, with the car. They have to, the student can collect your own data, for instance. You have to simulate your own data, because now we have to use data more as handmade data, for instance. Yeah? And last but not least, you can take special companies, excursion companies, automotive companies, for instance, professional companies, which can show here all the working, the development, the maintenance process, and so on. You can see the live process of the transformation of teaching or the education in the company know-how, for instance. And in a short video, we can see what the students are see, because automatic driving, the platooning driving of the car, as a practicum, as a real-time exposition, as a practical exercise. Sorry, the presentation had a little break and a little problem. Now we have a part 2 for this, and we see in video now some video sequences of real field text explosion process with students, which is made of automotive platooning processing with two. Because here you can see the live processing. So here the car, the wheel is rotating. For instance, here's the trajectory, here are the special signals. And step by step, I will make a little faster video. You see here driving cars, platooning. The first car is a leading car, and the second car is a full automated car, which will use the same trajectory, and the students are programmed the sensor, signal, raw data collection, the data fusion, and some things of the controlling unit. Last but not least, we come to the agenda point number 4, conclusion. Connected technology in the context of teaching. You see here 3 circles, because all the circle student content, the technical part, and the knowledge transfer. And we have the intersection from this with the main point, with the main topic is the application for this. And so we have the slogan, which you can read here. Transfer is affected by the degree to which people learn with understanding rather than merely memorize sets of facts or follow a fixed set of procedures. This is meaningful. And the second slogan and mainly aspect, for instance, is the central approach for teaching, for learning is the experience-based learning. Short EBL is a pedagogy of participant by John Dewey. And you can see that the workings to the contents principle on one side and the active reflective engagement with concrete experience, and this as an intersection over give the experience-based learning. And last but not least, we can say by learning you will teach, and by teaching you will learn. This is a meaningful slogan from the side from teachers and from the side of students, and you can take it otherwise clockwise to use it for overground processing presented in my keynote presentation. Yeah? So this is the finishing. Yeah? Thank you very much for your attention. Goodbye.
Yeah. Thank you, Professor Michra, for the presentation. It is quite interesting talking about the transportations that related to the perspective of our guest, the perspective on your country in Germany. And right now we are going to the question and answer session or discussion sessions. If any question from the participant, you may raise hand in Zoom. All the participant, if you have any question, you may raise hand up in Zoom. Or we can, there are so many questions right down in the chat box, but unfortunately, wait a minute. Professor Lee have to leave because he has a lecture right now, but he said in the chat box that he keep all the question with him and will be sent the answer by email in send the answer by the email to the committee, and we will provide the answer to all participants. And thank you very much for the questions given by the participant for Professor Lee. And then we have here Professor Ferry already joined with us right now. There are, if I'm not wrong, there are questions sent by the participant to Professor Ferry in the chat.
Sure. First of all, I would like to say thank you so much to give me the opportunity to have a presentation at this wonderful conference. Yes, please accept my apologies because I have the same time with the Congress and Summit meeting in California at that time. So, and then I'm trying to run away from the other building to join. So that's why I send you the recorded my presentation. But I'm more than happy to just answer the questions and provide the summary. So what we have this session, so ensure the participants can take the messages and informations about that session.
Yeah. Actually, there is in the chat, there is a question from the Tine Safara. Yeah. He says, good afternoon, Professor Chi. Thank you for your excellent speaker today. Tine Safara from Vocational Education, and she has a question regarding your presentations. Wait a minute. She said that we are now in the fourth industrial revolution, and one of the characteristics is the use of AI, artificial intelligence,
and ML, machine learning in any field. And you were previously talking about the big data analytics. So just curious whether you use EI or ML in analyzing the data you gain for the supply chain management.
All right. Yes, so very good questions. This is what we call the supply chain industry 4.0. The short answer is yes, because we have a machine learning, artificial intelligence, and now the extension of machine learning is what we call deep learning, introducing to the supply chain and logistic and transportation management. So as you can see, it's a growing for advanced technology, machine learning, and artificial intelligence. One particular, since you study at vocational study and introduce all across university in terms of the curriculum, when we teach the supply chain and logistic management, we include the technology advancement or convergent technology such as robotics, sensor, analytics, artificial intelligence, deep learning, as well as what we call the Internet of Things, right? So I have published one paper, the supply chain in the systematic literature review industry 4.0. So in terms of application of machine learning and artificial intelligence, I think one particular element is we need to consider whether the industry is ready. And number two, in terms of the education provider like vocational or institution across university, whether they provide any discipline such as supply chain or business or innovation or even engineering, make sure we also need to teach the student about those technologies. The reason is if we did not teach them, and it's very hard for them to what we call work ready once they graduate from university, right? So that's something we need to consider, think about it. And number three, in terms of the artificial intelligence and machine learning in the sector for supply chain analytics. So as you know, the supply chain big data analytics, the purpose is to do decision making for any kind of supply chain function or supply chain operations. So the machine learning is basically, and deep learning on artificial intelligence is simply can capture all the data. So, and then all the data analytics can be captured, and then it would be useful for decision making. So one particular sector in Australia, like hospital, mining sector, they use artificial intelligence and machine learning. And the most success story is in the pharmaceutical company and as well as hospital supply chain. They use it very good in terms of robotics, machine learning in the pharmaceutical company. Anyway, is that did I answer your question?
Yeah, it is quite clear, I think, Professor Ferry. There is another question provided by Mr. Amri Ristadi. He is one of our lecturer in our faculty. He provide two questions for you. The first one is, how is the supply chain management respond to the green energy requirement and climate change challenges? And the second one is, he saw at Woolworths product that the Woolworths have their own brand. What was the benefit of it from a supply chain point of view? Yeah.
Yeah, so I can start answering question in terms of the Woolworths, for example. Woolworths actually is the largest supermarket, as you can see. They use their own brand, what we call home brands, which is this is integrated supply chain that's implementing at Woolworths and Coles. and Cold Supermarket. So they have their own producer, they have their own uh, processing plant, as well as distribution center and warehouse, right? And then supermarket, of course. So that's number one. If that's integrated supply chain, you can make your own profit, the supply chain profit, and to reduce costs. And of course, you need to deal with your own branding. That's what we call home brand, right? And now with the question one, in terms of the climate change, that's a sustainability supply chain, it is more appropriate in some particular more than 21 countries in relation to the United Nations Development Goal, which is UN, what they call SDG, Sustainability Development Goals, provided by United Nations. That 22 countries, they decided in terms of supply chain sustainability, they're ready to have net zero, which means that they're trying to reduce carbon emission to improve the impact on the climate change initiative by 2050, right? So if you look at sustainability development goals and all the 22 countries, majority Europe, Asia Pacific, including Australia, they promote actually climate change initiative. So climate change initiative, if you can see, that's a triple bottom line. I think in my presentation, I mentioned the economic, social, as well as environmental impact. Now, environmental impact, that one particular element is the climate change. Now in Australia, we introduce climate resilience, right? In the area of the sustainability supply chain context in Australia. So in the 2025, we are in the progress introduce a carbon tax, for example, net zero initiative, or carbon to reduce the level of CO2, right? So that is what we call that in the progress by 2025 towards 2050 in order to achieve accomplish sustainable development goals, SDG. Okay, so that is in the big picture, what we call the short answer is yes. Sustainability supply chain definitely having a influence, the impact on the climate change. Yeah.
Yeah, thank you. Yeah, we have here Mr. Amir us. Is the Professor Ferry as well meets your questions, Mr. Amri?
Yes, thank you for the answers.
Yeah,
very clear.
So,
yeah.
Amri, if you
Thank
want
you.
to ask and further discussion for the research publication together, I provide my WhatsApp number and email. And feel free from university or UNY if you want to work together for research as well as publication. Please text me messages and what we can work together for the research. And we want to see a lot more papers from University Negeri Yogyakarta, as well as from Indonesian scholars, and to publish a lot more papers from the research project. Right? So feel free if you want to text any messages, questions. I provide my WhatsApp numbers there.
Yeah, thank you, Professor Ferry. Mr. Amri, if you have any questions more, you may ask directly to Professor Ferry.
Okay, thank you. Much appreciated, Professor Ferry.
It's amazing. We have 563 online participants. So I can see it's a great conference. I wish to visit Yogyakarta, in person, maybe next year, if organize again the conference. I would love to visit Indonesia, right? Any questions, ladies and gentlemen?
Yes, yeah. Thank you, Professor Ferry. Yeah. Actually, we have another question, but it is for many questions for Professor Lee, but Professor Lee cannot join with us right now because he has a lecture. And what about Professor Michel from Dresden? No, okay. Yeah, Professor Ferry, is it also possible for us to join, for example, to make a joint publication and joint research with you, right?
Of course, definitely.
Yeah.
Definitely, because I mentor quite a lot of Indonesia scholars, like from Diponegoro University, UGM, and then Pajajaran University in Jatinangor, Bandung, and as well as ITB and UI, and then Unsri in Palembang. And all my doctorate students, they graduate from my uni, and now they become, hopefully become guru besar, you know, as a professor. And then two of them, they got guru besar professor already from Undip, and then one from University Muhammadiyah Malang, okay? Professor Dr. Ilyas Masudin. He's now the Dean of Faculty of Engineering. He was my doctorate student. Okay. All right. So hopefully for this conference, we built, you know, good network and collaboration for research in that opportunity, right? So if we can do research together, we publish together, and that's a good opportunity for all of us, okay, through this channel for the conference. So maybe I just would like to say thank you so much once again to invite me to be a speaker for this conference. And I would like to say all the best to you all, and please keep in touch. And yeah, I send you all my email and also my WhatsApp number, so you all can add me and then just ask question on what particular we can do research together. Okay, so thank you so much. I would like to say all the best, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. We have still time actually, but I will ask the participant if any participant has questions, you might raise hand. Okay, I think it's enough. Okay, yeah. Thank you so much. And we are going to the end for these sessions. And I apologize for any inconvenience. And for the token of appreciation to all the excellent speakers in this second plenary session, we may give a virtual applause. Yeah, thank you very much. And I hand over this floor to MC, Ms. Nunit. Thank you.
Thank you very much. All participants, ladies and gentlemen, this is the end of plenary session 2. And as an expression of gratitude and appreciation, we would like to present certificates of appreciations to the speakers. The first one is for Associate Professor Ferry G, PhD, FCILT, FCS. And then the second certificate is addressed to Professor Dr. Ing Lee Soon-ha. And then the one is for Professor Dr. Ing Oliver Mihler. And of course, our special gratitude goes to the session chair, Dr. Phil Insinyur Dr. Didi Haryanto, MD, for running the session successfully. Ladies and gentlemen, before the break session, please be well informed that the parallel session starts in an hour, or exactly at 1 p.m. And then the links for the parallel sessions from the ICSI, ISO-FIMAT, and ICL-Info are shown on the screen. And the ICT-VT links from the 7 rooms, besides being shown on the screen, can also be accessed in the conference book. And that's all about the announcements for now. And it's time for us to have a break. And later on, make sure that all of you join the parallel sessions in an hour from now. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. To those who are present offline, would you please take a place, position yourself at the front of this room to have a photo session together.